grade 10. So this is our equivalent virtual class. So instead of meeting you, since there is a conflict of time, so I will just record our discussion. Okay. So last week in your self-paced, you've been introduced with the um, trigonometric functions, the SOHCAHTOA, using the SOHCAHTOA, as well as solving triangles and the unit circle. So today, we will explore about trigonometric identities. So, what do you mean by trigonometric identity? Okay, where's my cursor? So let's consider these two groups. We have group A and group B. So group A here is the conditional equation wherein some values of x will satisfy our equation. So that's why this is called conditional equation, because it's conditional. There is a certain condition for the equation to be true. While in group B, this one is an identity, or these are identities, because whatever value of your x, it will still satisfy our equation. So, miski unsa pa ning value ni x diri, kung 1 pa ni si x or 2 or whatsoever, true gihapon ang atoang equation. So, this is a difference between conditional and identity. So, in relation with that, when we say trigonometric identity, or when we say identity, it's any equation that is true for every number in the domain of the equation. So, meaning whatever values of your x, it will make our equation true. Okay? So, such as 3x plus 18. So, this is an identity by distributive property. Similarly, trigonometric identity is an identity involving or based on trigonometric functions. So, such as tan x equals sine over cos. Sine x over cos x. So, there are some trigonometric identities that you must be familiar with. So, these are the following. Okay. So, these are the trigonometric identities. The very basic one is the ratio identity. Ratio, we have tan x equals sine x over cos x, as well as cotangent x is cos x over sine x. Take note that cotangent is just the reciprocal of tangent. So that's why cotangent is cosine over sine, since tangent is sine over cos x. Same thing here, the reciprocal identities, which was presented last week in your self-paced. You know that the reciprocal of sine is cosecant, and the reciprocal of cosecant is sine. The reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. So these are your basic trigonometric identities. Aside from this, we have another identity, which is using the Pythagorean theorem. We have the sine squared x plus cosine squared x is just equal to 1. 1 plus tangent squared x is equal to secant squared x. These are your basic Pythagorean identities. So I'll just box the most common and most used trigonometric identities. We have also negative angles. Sine negative x is just equal to negative sine x. Meaning the trigonometric function of a negative angle is just equal to negative of the trigonometric function of that angle. So when we say sine negative 90, this is just equal to negative sine 90. Okay? So, kaning akong mga gipangbaksan mo ni ang usual nga or most common nga trigonometric identity nga gamiton. Okay. So, take note of this. Familiarize. You do not need to memorize, just familiarize with these trigonometric identities. Okay. So, example number 1, express the following in terms of sine and cosine. Sine and cosine are the most common function, trigonometric function. So, that's why sometimes most of the time, we express the trigonometric functions into sine and cosine. So, let's have here tan Take note that tangent theta is theta. Tangent theta is sine over cos. So we have here sine theta over cos theta plus cotangent. Cotangent is cos over sine. So plus cos theta over sine theta. We simplify just like an algebraic expression. So we just combine our two fractions. So the LCD between the two is sine or cosine, sine theta and cos theta. So sine theta cos theta divided by cos theta is sine. Times sine theta is sine squared theta plus sine theta cosine theta divided by sine theta is cosine times cos theta, that's cos squared theta. So take note that sine squared theta plus cosine squared theta is also an identity which is equal to 1 by Pythagorean identity. So we can say that this is 1 over sine theta cos theta. Okay, so your final answer is this one. So this is the simplified form and at the same time, the expression in terms of sine and cosine function. Okay, so this is for letter A. So I'll just write it here. Take note that sine theta cosine theta divided by cosine theta, makancel na siya. So ang equal kay sine theta nya mooning kani nya dayon times sine theta, so mo na siyang sine squared theta. Similarly, sa kaning sa pikas na sad, we have sine theta cosine theta over sine theta, makancel si sine, ang nahabilin kay si cosine theta times the numerator. That would be, so mahimo na siyang cosine squared theta. So again, take note ha, we divide and then we multiply. We divide the LCD and then multiply. Okay, another example, we have here secant x over cosecant x. So take note that secant x is the reciprocal of cosine. So this is 1 over cosine x divided by cosecant x is the reciprocal of sine, diba? Tara, reciprocal function, cosecant and secant. So we have here divided by, where's my cursor? So 1 over sine x. Take note, the rule for fraction, we take the reciprocal of our divisor and then proceed to the rule of multiplication. So mahimo na siyang 1 over cosine x. Instead of division, mahimo na siyang multiplication, ya ma-reciprocal na siya. So mahimo na siyang sine x over 1. So this is sine x over cosine x. So this is the function in terms of sine or cosine, or the simplified form for this is tangent x, since sine over cos is tangent. Alright, so take note of these. Just remember the basic trigonometric identities. Letter C. So cosecant is the reciprocal of sine. So sine squared x minus cotangent. Cotangent is the reciprocal of tangent, and tangent is sine over cos. So this is cos squared x over sine squared x plus sine squared x. We do not need to change sine squared x because it's already sine function. So this is over 1. We can find the LCD between the three fractions, which is sine squared x. Sine squared x divided by sine squared x is 1 times 1, that's 1. sine squared x divided by sine squared x is 1 minus cos squared x plus this is times 1, so sine 4x. Okay, sine squared x divided by 1 is sine squared x times sine squared x, so sine 4x. So, you know that this is 1 minus cosine squared x is sine squared x by trigonometric identities, because you know that sine squared x plus cosine squared x is equal to 1. So, meaning if we transform it, so meaning sine squared x is equal to 1 minus cosine squared x. So, mo ni siya. Mo ni. Okay, so take note. So, plus sine 4x over sine squared x. And then, we find the common factor between the numerator. Ang common factor ano niya kay sine squared x. So, ang mahabilin diri sa first term kay 1. Ang mahabilin diri kay sine squared x over sine squared x. Then we can now cancel the sine squared x. So ang answer kay 1 plus sine squared x. So this is now your final answer. Okay, so ang sige buhat na today, we look for the LCD. Then we simplify. Alright, so let's simplify again, letter A. So same thing, just use some trigonometric identities to simplify and later on to prove and verify trigonometric identities. So we need to rewrite our tangent, since cosine and sine are the basic trigonometric function. So just copy cosine x. Tangent is sine x over cosine x times sine x. So we simplify, this is cosine x. Sine x times sine x, that's sine squared x over cosine x. We get the LCD, this is over 1, right? This is over 1, so we get our LCD between the two fraction, which is cosine x. Cosine x divided by 1 is cosine x times cosine x, that would be cosine squared x, plus cosine divided by cosine, that's 1, times sine squared x, that's still sine squared x. Take note that the identities used here, this is Pythagorean, diba? This is Pythagorean. So that's equivalent to 1 over cosine x. And 1 over cosine x is secant. So the simplified form for our function is secant x. Okay. Next, letter B. We have sine x plus cotangent x, then cos x. So we transform our cotangent x. You know that cotangent x is equal to cos theta over sine theta, right? So, by definition, I mean by trigonometric identities, you can go back to the set of trigonometric identities in the previous slides. So, we have here sine x, cotangent x is cos x over sine x times cos x. Actually, this is just the same thing with letter A. So, sine x plus cos squared x over sine x. We find our LCD between the two fractions. This is over 1. So, the LCD between the two is sine x. Sine x divided by 1. Sine x divided by 1 is sine x times sine x is sine squared x plus Sine x divided by sine x is 1 times cosine squared x is cosine squared x. And again, this is Pythagorean theorem. Pythagorean identity, which is equal to 1. So 1 over sine x is just equal to cosecant x. So this is now your simplified form. We have here 1 plus tangent squared theta over 1 plus cotangent squared theta. So we need to rewrite our tangent and cotangent. So 1 plus tangent is sine squared theta over cosine squared theta divided by 1 plus cotangent is cosine squared theta over sine squared theta. Okay, so we get our LCD on our first group. So we have cos squared theta. Cos squared theta divided by 1 is cos squared theta times 1. That's cosine squared theta plus sine squared theta. Divided by, we get also the LCD of our second group, which is sine squared theta. So sine squared theta divided by 1, this is over 1 and over 1. So that's sine squared theta plus cosine squared theta. Okay, wait, let me write it. So by Pythagorean identity, cosine squared theta plus sine squared theta is equal to 1 over cosine squared theta divided by, still, this is Pythagorean, which is equal to 1 over sine squared theta. So that would be, this is division, so we take the reciprocal of our divisor and proceed to multiplication. So that will be 1 over cosine squared theta. From division, it will be turned into multiplication and reciprocate our divisor. So the sine over 1. So this is, and 1 times sine squared theta is sine squared theta. Cosine squared theta times 1 is cosine squared theta. And sine squared theta over cosine squared theta is equal to tangent squared theta. So this is now your simplified form. Alright. Letter, okay. So we are done with simplifying. So let's have here the verification of trigonometric identities. So there are two ways to verify an identity. You can express one side of the equation and manipulate it independently to make it the same with the other side. Let's say if you are going to manipulate with the right side, make sure you manipulate it until it will look exactly as the left side. Or another way, you can manipulate both and then they will arrive with the same expression. Okay, but most of the time, the easiest one is to manipulate one side. But if the given expression is kind of complicated, so you manipulate both sides. Okay, so here, verify the following identity. So, to make it easier, you always manipulate with the complicated one and then arrive with the simpler expression. So, in this case, we manipulate cosine theta, cosecant theta. So, take note that cosine is the basic. So, we transform the cosecant. So, cosine theta times cosecant is 1 over sine theta, which is equal to cosine times 1 is cosine theta over sine theta. And this is already equal to cotangent theta. So, end na. So, meaning it's already verified. Very easy. Okay, so we have here letter B, cosine squared x minus sine squared x equals 1 minus 2 sine squared x. So in this case, I'm gonna choose the left side and transform it. Same thing with the right side. So I'm gonna use the Pythagorean theorem, which is sine x plus cosine squared x equals 1. So supposing I'm gonna transform or looking for our sine x or cosine x, either way, so I'll just choose cosine. So cosine squared x is equal to 1 minus sine squared x. So cosine squared x is equal to 1 minus sine squared x. So this will become 1 minus sine squared x minus sine squared x. So take note that 1 minus sine squared x minus 1 minus sine squared x is equal to 1 minus 2 sine squared x. So that's 2 sine squared x. So our identity is already verified. Next, letter C. We have here sine theta, tangent theta equals 1 minus cosine squared theta over cos theta. So, we are going to manipulate our right side of our expression. So, we have 1 minus cosine squared theta. That's equivalent to sine, right? Since you know that sine squared theta plus cosine squared theta is equal to 1. So 1 minus sine squared theta is equal to 1 minus cosine squared theta if we transform it here. So this can be written as sine squared theta over cosine theta. Take note that sine squared theta can be written into sine theta times sine theta over cosine theta. I'll break this down. So this will become sine theta over cosine theta times sine theta over cosine cosine theta. I mean since one cosine naman, so this is just sine theta times sine theta. Sine theta over cos theta is tangent theta. And just copy sine theta. By commutative property, this is sine theta tan theta. So, verify. Okay. Last example. I think this is the last one. Cosine x equals secant x minus sec x sine squared. So, I'm gonna manipulate our right side. So, secant is 1 over cos x minus secant still cos x. And I'll just copy sine squared x. Okay, so this will become 1 over cos x minus sine squared x over cos x because you multiply this. Combine the two fraction. Their common, the LCD is cos x. Cos x divided by cos x is 1 times 1, that's 1. Cos divided by cos, that's sine squared x. And you know, this is Pythagorean because sine squared x plus cos squared x is equal to 1. We transpose our sign here. So cos squared x is equal to 1 minus sine squared x. So this is your identity. So this is cos squared x over cos squared x. We can cancel out because you know that this is equal to cos x times, wait, let me rewrite it again. Kay bati siya og agi. Or we can cancel out directly. Cancel out 1 and and another cos x. So our final answer would be cos x. And we already verified our trigonometric identities. Okay, so the strategy here in verifying identity is to make sure to simplify your trigonometric expression by rewriting it into sine and cosine. So once you do that, everything will follow. Just follow the algebraic rule. You combine the two fraction, find the LCD, and then simplify. Okay, so that's it.